All right, check, check, 1, 2. Looking good. What is up, everybody? Welcome to the channel. My name is Eric, and in today's video, I'm going to teach you how to reconstitute your peptides. Not only how to physically put the water into the peptide vial, but the math behind it. I'm going to tell you what's really been bothering me. I've been dealing with peptides for a little bit now, and people tell me their dosages, I'll ask, I'll say, so how much BPC 157 are you taking? And it never fails. Most of the time, people are going to answer in units. I'm taking 20 units. And I'll be honest with you, I don't know what that means. I don't know the concentration of that vial. I don't know how much water you added in, how much milligrams was in the vial to start with. I don't know any of those. So 20 units tells me, oh, you know what that tells me? Here's the insulin syringe, right? It goes from 0 to 100, 100 units. 100 units is equal to 1 milliliter. So if someone tells me they took 20 units, all right, I know they took this much. I don't know what their dose is. That's not a dose, really. That's telling me how much fluid they put into their syringe. 20 units is the same as 0.2 milliliters. That's the only thing I know when you tell me that. So I'm going to rectify the situation so that you understand the difference between units, milliliters, and milligrams. All of those things are important to know, and we're going to get into it right now. Don't worry, it's not hard, super easy. Let's get into it. Okay, here we are at the whiteboard. I want you to think about this as being two different fractions, all right? It's not too bad. So I have a fraction over here and a fraction over here. I'm going to talk about this side first. So this first fraction is going to be our peptide vial, all right? I even have like a visual. We'll call this side the peptide vial, right? And on the top, we'll keep milliliters on the top, milligrams on the bottom, just and keep it uniform. But on the top, this is the amount of bacterial static water I'm going to put into this vial. On the bottom here, this is the total in milligrams that is in the vial. This one in particular is BPC 157, 20 milligrams, 20 milligrams. So I would put 20 for this one. Our other fraction, this is going to be our syringe, okay? Essentially, I'm going to consider this fraction as our syringe. The top number here is in milliliters, and that's going to be the amount of fluid that we're going to draw into this syringe in order to get our desired dose, which will be on the bottom here, and that's going to be in milligrams. Milligrams is the dose. Milliliters, or units, is going to be the amount of fluid to get that particular dose. All right, pretty simple. So generally, we know most of these things. I have a little circle here because this is pretty much what we're always trying to find. If I know my dose, right, and I know how many milligrams is in a vial, and I know how many milliliters I put into that vial, what I'm not real sure of, or I want to be sure of, is how much to withdraw into that syringe. And I'm going to show you that if we know these three variables, I can tell you what this is pretty easily. Simple. It's a pretty simple process. So here we go. Let's just do an example. I'm going to try to do an easy one to start off. Okay, reconstitute, 10 milligrams. Okay, so this is our peptide vial. So let's say 10 milligrams is the strength that's in that vial. That's the weight. Milligrams is weight. The amount of bacterial static water I want to add into this vial. That's what I'm going to put up here. Now, look, these vials, these are 3 milliliter vials, guys. Honestly, the majority of the time you're going to put 2 or 3 milliliters in. You could put 1. It's dependent. And we're kind of going to, I'm getting ahead of myself here, but we generally are going to have a good idea of how much we're going to put in there. So just for simplicity's sake, I'm going to put 1 milliliter into this 10 milligram vial of reconstitute. On my other side, this is what I should know, all right? If I'm reconstituting this, getting ready to take peptides, I should know what my dose is going to be. So just for simplicity, let's make it 1 milligram, all right? 1 milligram. So now that I have this, all right, I've got my 3 known variables here, and I want to know, man, if I want to take 1 milligram, how many units do I need to withdraw in order to get 1 milligram? So here's what we do. We're going to take, all right, you're going to have one fraction that's complete, one that's incomplete. You're going to take the opposite of this fraction here. So the numerator times the denominator of your syringe, the numerator of your peptide vial times the denominator, right? This is super easy. I'm making it complicated. You're going to multiply these two numbers. Okay. You're going to multiply those, and then you're going to divide the answer by your remaining number here. So always get your calculator out. This is going to be super simple. I could do it without a calculator, but generally just get the calculator out and use it. All right. So 1 times 1, we know is 1. So 1 divided by 10, that's going to be 0.1 milliliters. 0.1 milliliters. So in order for me to get 1 milligram dose, that's how much I need to withdraw in the syringe. Now you might be saying, okay, 0.1 milliliters, where is that on the syringe? So here's how we convert it. To convert milliliters to units, right? You're going to take your answer in milliliters times 100. Okay, and if you guys remember, anything times 100, right, you can just move the decimal place over twice. So we'll say 0.1 times 100, right? I'm going to move this decimal place over twice, and that's going to give me 10. So this is equal to 10 units, all right? So I'm going to withdraw into my syringe 10 units. And that will make sure that I get the correct dose for whatever peptide you're using. Okay, super simple, very easy one. Let's change it up just a little bit so we have a little variation. What I'm going to do now is I'm going to change my dosage. And I'm going to change how much in milliliters I put in. Let's keep the milligrams the same, but we're going to change a couple things. I'm going to put 2 milliliters in here this time, and this time I want 0.5 milligrams. Okay, 0.5 milligrams. So I'm going to get my handy dandy calculator out here because I don't want to mess this up. And I'm going to take 2 times 0.5. Now we get 1. So 1 divided by 10, what is that? 0.1 milliliters, which is equal to 10 units. Okay, I want you to see what I just did there. I told you 10 units for the first one. Guess what? I changed a couple of things around. 10 units for the second one, totally different dose. Do you understand why it drives me nuts when people say, I'm taking 10 units? I just showed you 2 examples where the dose was different, but the measurement of fluid is the same. That's all I'm saying. That's all I'm saying. Now you can see it clearly. All right, now let's see. Let's just do one a little bit different, a little bit off, a little bit more random. Okay. I'm going to change this to, we'll keep the 2, well, let's go 3. Let's go 3. We'll go 3 milliliters and whatever's in here. I don't care what it is. It doesn't really matter. I'm going to say, let's go, it's a 20 milligram. Okay. 3 milliliters and 20 milligrams. And let's say I want to take 2.75 milligrams. Crazy dose here. We're still going to be able to figure this out pretty easy. So here's what I'm going to do. I'm going to take the 2 numbers, my numerator times my denominator, 3 times 2.75. That gives me 8.25. And I'm going to divide 8.25 divided by 20. That gives me 0.4125 milliliters. Right? So what does that tell me? All right, I got to convert this to units. Multiply it by 100, move the decimal over. It's essentially going to be 41 units. Okay, 41 units. So if I have a 20 milligram vial of whatever, I had 3 milliliters in there. If I want to take 2.75 milligrams, I'm going to withdraw 0.41 milliliters, or in other words, 41 units in the insulin syringe. Okay, so hopefully after seeing this a couple times, going through a couple different variations, you're able to understand how to do the math on the reconstitution so that you can accurately dose yourself. All right. Let's be careful out there. Some of these peptides, maybe not a big deal if you get it off. Like the BPC 157, not a big deal. But your retatrutide, your tirzepatide, and several others, you want accurate dosing. So, all right. Now to the next part, actually reconstituting a vial of some peptide. All right. So let's actually physically put this bacteriostatic water into this peptide vial. So first thing you're going to need a couple supplies, right? But you're going to need a good high quality peptide, right? Today I got BPC 157. This is a 20 milligram vial. Make sure your peptides are tested for endotoxins, heavy metals, yeast, molds. Make sure the assay is there. Is 10 milligrams actually 10 milligrams? This is 20. But all that stuff's important. All right. Make sure you get good peptides. If you get it from pinelandpeptides.com, you're good to go. Next thing you need is bacteriostatic water. Bacteriostatic water is the preferred, it's the gold standard. Can you use just sterile water? Yeah, you can. Like if I was going to take this entire vial in one dose, sterile water, no problem, all day long. Maybe even if I was going to take it within a week, that wouldn't bother me. But if I'm going to keep this in my fridge for any period of time and I'm going to inject a needle in and out, we want to avoid introducing any bacteria into that vial. So let's stick with the bacteriostatic water. It's the best thing to do. All right. Other people have asked about normal saline. No, I wouldn't put, I mean, if I was going to take it the same day, probably no problem. But the problem with normal saline is it has a little bit of salt in it. And what does salt do? It degrades, corrodes. I don't know what it would do with this peptide. These peptides are expensive. Let's take care of them. Just use bacteriostatic water. That's enough on that. Next thing you need is some alcohol pads so that you can clean the surface before you puncture the tops of the vials and also your skin. Obviously, you're going to need an insulin syringe. This is an individually packaged sterile one. Sometimes they come in a bag like this, like a 10-pack. It's not a big deal either way. I mean, this is preferred because it's sterile. There's a 100 unit, there's a 50 unit, and there's a 30 unit. And depending on if you're going to dose really small doses, I would go with the 30 unit. This makes it easier. It's easier to see the syringe. And then the last thing we're going to need is a needle for reconstitution. You don't have to use this. You can actually use the insulin syringes, but I prefer using a 3 milliliter, 1-inch needle. I think this is 23 gauge. It doesn't really matter, right? I'm just going to simply take the water from here, put it in there. It's easier to use with a bigger needle, easier to use with a bigger syringe because this only holds 1 cc or 1 milliliter. And if I want to put 3 milliliters in here, I got to withdraw 3 times, makes it a lot easier. All right. So, all right, that's all we need. All right. So let's go ahead and get it started. First thing I'm going to do is just unpackage everything. All right. So as you can see, my vial has a little top on the top right here. I'm just going to peel that back, pull it right off. This one had one on there. I've already used it. All right. So I'm just going to simply pop the top off here. All right. Sometimes this little metal part right here, see, not a big deal. Don't worry about that. Sometimes that happens. Not a big deal. Just bend it over, bend it back, bend it out of the way. No big deal. You can clip that off. I'll probably just clip that off. I don't want to pull the whole thing off, but sometimes that does happen, guys. Don't worry about it. But you can kind of see right there in the middle, there's my bullseye. I want to stick that needle right there in the middle. The reason I'm saying that is because if you kind of go to the side and you've never done this before, there's some thick rubber that's kind of around here on the side. And if you don't go directly in the center right there, then your needle is going to go into the rubber. It's going to be hard to withdraw anything, if you can even withdraw anything. It sounds simple, but I see so many people doing it. Make sure you just go straight in. So let's prepare everything. I'm going to take my alcohol pad, open it up. I'm going to rub it real quick over the top of both of my vials. I'm going to let it sit there because the way these alcohol pads work is as it dries, it kills the bacteria. And by the way, if your alcohol pad is not wet, it's not good. Toss it, get another one. Sometimes that happens. All right, now I'm going to take my reconstitution needle, which is my 3 milliliter syringe with a 1-inch needle at the end. And I'm making sure I'm going to go straight into the top, just put the needle right in down the center, turn it upside down, and then you're going to just withdraw And try not to get any air bubbles in there. You might get some air bubbles in there. It's okay. And you might have to work it in and out. Sometimes if I get a couple air bubbles in there, man, I'll just flush it all the way out, push it all the way in, and then just redraw, right? And a lot of times that will get rid of that air bubble for you. But other times with this bacterial static water, you can flick it and the bubbles will go to the top and you can flush them out. But anyways, this one's a pretty good draw here. Doesn't look like there's really any air bubbles. And I'm going to go to that 2 milliliter mark. All right. Now, what I'm going to do is simply take this 2 milliliters. I'm going to get it right in the top. Now, I got to tell you guys something about this. There's going to be a vacuum. When you stick this needle in there, it's going to suck this water right in there. And what we don't want to do is like have an explosion come right down on all that liphophilized powder. So this is a powder form. Obviously, you can see that. But right now, it's pretty stable. Once we start reconstituting it, it becomes much less stable. And so we don't want to shake it. We don't want to, do anything crazy with it. We want to slowly introduce water into this vial. All right, so I'm going to hold on to this plunger. This is the plunger at the end right here. I'm going to hold on to it tight and not allow it to just suck it right in. I want it to slowly dribble the water down the side of the vial. And I'll try to get that on camera if I can here. Let me move this mic. So I'm going to enter the needle into the vial. And as I do that, it's going to suck it in. You'll see. All right, so it's sucking. You can't tell, but I'm really holding the plunger down. And maybe you can see that. I'm just letting it slowly drip. Okay, see that? Slowly drip down the side of the vial. Okay, nice and slow. All right, now all the water's in there. I pull out. Always cap your needle. You might have kids or dogs or whatever. This thing falls on the floor. Safety first. Now I'm going to take this vial and I'm just going to swirl it in my hand. All right, I'm not going to shake it. I'm not going to get crazy with it. Just a nice, easy swirl. Some peptides will reconstitute really quickly. It's like, 30 seconds. Retatrutide seems to be really fast. Others take a little bit more time. And a lot of it has to do with the milligrams or how much is in the vial too. So anyways, I'm going to rock this for maybe 1 or 2 minutes and I'll come back and this will be totally clear and ready to rock. And you can kind of see, I haven't quite got it all. There's still some chunks down there. Again, you're going to want to something in you is going to say shake, but don't shake, right? And these will just eventually dissolve. I'll just keep rocking, keep rocking, keep rocking. I just spin it in my fingers, man, whatever. This one's taking a little bit long. I don't know. It's only been a couple minutes, maybe not even. You can kind of see those little things are starting to dissolve. All right. Now you can see all of those little things. Oh, there's one little thing right there. Just a couple more seconds of swirling, that thing will be gone. All right, cool. Looks like it's totally clear. It's not cloudy. There's no particles in there. BPC 157, reconstituted. Now, I got to tell you, don't forget, put these things in the fridge. You don't want to leave these sitting out. Once it's reconstituted, it becomes, we're going to treat it as fragile. All right. There's a debate out there. Some people say you can shake these things up. I think they cost too much money to even, consider taking the chance. So just go nice and slow and it will reconstitute pretty easily. Don't worry about it. But now this is essentially ready for you to take your dose. So if I'm going to let's do the math, right? I wanted to take 1 milligram. You saw me put 2 milliliters into this 20 milligram vial. That gives me a 10 milligram per milliliter concentration. So if I want to take 1 milligram, I'm going to withdraw 0.1 milliliters, right? 0.1 milliliters. So I had to think about it. And then that's going to basically be 10 units. So in order for me to get my dose that I want, I'm going to withdraw 10 units into this bad boy, stick it right in my belly. There we go. So now hopefully you know how to reconstitute peptides. Thank you for watching. I appreciate it. This stuff is important. If you're going to take your health into your own hands, you got to know this stuff. I know it's kind of boring. I get it. But yeah, you got to be smart on it. All right. So that's all I got for you. Have a great day. Stay strong. Stay in the fight. I'll see you on the next one.